Again, I realize that you're not alone in this. If you see this over here and say, oh, what do I do about that? Before I say anything, I want to point out to you, when you start at 1, whatever you do, the top's always going to be positive when you start at 1, all right? And, if I start at 0, that would be not a good place to start because the bottom would be undefined. But the top is always positive. I mean, that n squared really grows much faster, and cosine just bops around a little bit, all right, between plus or minus 1. So what are we going to do over here? Find a comparison. Oh, look at this over here. I'm not too worried about that cosine. It plays very little role in the long-term behavior of the problem. I'm going to say it sort of looks like n squared over n4, which is really 1 over n squared. And this is a convergent P series. What am I going to do over here? Limit comparison test. All right, that's what I'm going to do. It's the easiest thing for me to do. Let's write it down. Limit n goes to infinity. I'm using a limit comparison test. N squared minus cosine n over n4 times, well, it's really divided by 1 over n squared, but I'm multiplying by the reciprocal, n squared over 1. Let's write that down. Limit n goes to infinity. What do you get there? N squared minus cosine n over n squared. What does this give me? Limit n goes to infinity. This will give me 1 minus cosine n over n squared. Now, certainly as n goes to infinity, cosine n divided by n squared goes towards 0 very quickly. This is just going to be the number 1. All right, what do I know? But a limit comparison test, this series actually converges. It's a positive term series, by the way. Let's see if that's been written down. Yeah, we got it. Converges. Thank you.